Welcome to the Marine Biologist podcast. Join us to discover the latest ocean topics from leading marine scientists and conservationists. The podcast accompanies the Marine Biologist, the magazine for members of the Marine Biological Association, and is presented by the editor, Guy Baker. We hope you enjoy this episode.
Welcome to the Marine Biologist podcast. We're honoured today to welcome Professor Stephen Hawkins, an experimental ecologist who's worked on rocky shores for 60 years. He's Emeritus Professor in the School of Ocean and Earth Sciences at the University of Southampton and Lancaster Research Fellow at the Marine Biological Association. Steve was also Director of the MBA from 1999 to 2007. Welcome, Steve. Where are you joining us from?
I'm actually in my wife's flat in Switzerland. She, until quite recently, worked in the Swiss pharmaceutical industry. A job that actually was not that compatible with my career as a marine biologist, as they see in Switzerland.
First of all, what three things should we know about you?
Well, I can be pretty grumpy before 10 o'clock in the morning, except if I've got up early to get to work a good tide. I'm an outdoors person. Most of my hobbies are things like going fishing or surfing on my 1960s plywood board that I've had since I was 12. I quite like walking in the country. I like walking in Switzerland. I enjoy skiing, which is going to be compromised by the fact I'm getting 2 new knees over the next couple of years. Yeah, I've always appreciated nature, and the other thing is I'm a pretty sporty sort of person. I've never been very good at sports, but I've always been competent at things like cricket, rugby, football, field hockey. Not too bad at tennis. So I've always enjoyed playing sports, but probably not spent as much time playing sports as I should have done, because unfortunately sort of work in general and rocky shore in particular sort of has been probably the major thing I've spent my life on over the last 45 years or so.
When did you first work on rocky shores?
My first encounter with rocky shore ecology was actually on a field course on the Isle of Man. I was a student at Liverpool University, and in those days Liverpool University had a marine lab on the Isle of Man that had been founded in 1892, sadly closed in 2006. And on a first-year field course in 1974, we did the inevitable examination of zonation on the seashore and also size and shape in limpets, based on work that J.H. Orton, who works at the MBA before going on to Liverpool to become professor there, had started in the 1930s. So this was my first introduction. And then the first actual bit of proper research I did on rocky shores was a 3-day project on an Ecology field course on the Isle of Man, led by George Russell. I actually looked at the seaweeds growing on limpet shells and the seaweeds growing in the surrounding area, the grazed area around the limpets, because the seaweed shells were a refuge from limpet grazing because they're not very agile. And that sort of got me interested in seaweeds, and it also got me interested in limpet-seaweed interaction. So that was the first 3-day bits of research I did as a second-year student. And then I decided to do my final year research project, my honours year research project on rocky shores, which I did with Richard Hartnell, who then went on to become my PhD supervisor. So it is actually 50 years this year that I've been interested in working on rocky shores. Previously, I was a bit more interested in fish.
And when did you first visit the Marine Biological Association?
I first visited the Marine Biological Association in 1978. I went down to visit Alan Southwood. I was interested in doing a Natural Environment Research Council personal postdoc, and for it to be hosted at the Marine Biological Association. I'd heard Alan give a very, very good talk at a European Marine Biology Symposium on the Isle of Man about recovery from the Torrey Canyon oil spill. And I decided that this guy was the guy I wanted to do my postdoc with. And also my PhD had followed up some of the work that had been done on the Isle of Man in the 1940s by a guy called Norman Jones, who was one of Orton's students, and also by Alan Southwood, who was supervised by Orton. And I was aware of Alan's work because I was following it up. But having met him, I went down to discuss a fellowship with him that I would apply for. And I went and visited, and I then wrote the proposal, which Alan had a look at and said it was full of jargon. But obviously the jargon worked because I got the fellowship, and I ended up getting a 3-year postdoc at the Marine Biological Association, which I started the following year. So my first visit as a worker to the MBA was in December 1979, when I started my Natural Environmental Research Council, NERC, funded personal postdoctoral fellowship.
And Alan Southwood was a hugely influential figure in Rocky Shore ecology, wasn't he?
Not just Rocky Shore ecology. I mean, he did so many different things. He worked with his wife Eve on Pogonophora, gutless worms, which then led to work they did on hydrothermal vents when large Pogonophora were discovered. He did a lot of work on plankton and fisheries in the English Channel in relation to climate change, also using Rocky Shore animals as indicators. He did some fabulous work on recovery from the Torrey Canyon oil spill. I mean, he was a real polymath. And in those days, there was a small permanent staff at the MBA, and they were encouraged to work on what they wanted to work on. And Alan did a lot of things. I think he was asked to take on the plankton work, which he hadn't done previously, to basically inherit it from Sir Frederick Russell when he became director of the MBA. So if you wanted to ever find Alan, on a Saturday morning, he would be in the lab looking at a plankton sample that had been collected the previous day, which he would examine fresh. And I knew when I was doing my postdoc that if I went and knocked on his door at about 12:30, he would have just finished his plankton sample, and he'd have time for a chat for half an hour before going back for lunch at the house in Plymouth. So yeah, he did a lot of different things, but his Rocky Shore work was basically the precursor to what I did my PhD on, which was on interactions between limpets, barnacles and seaweeds, and how that determined distribution patterns on the seashore, and also community structure, particularly patchiness. I was very interested in patchiness at an early stage of my career.
Yeah, and that begs the question, why are limpets so important?
Well, I would say they are the keystone grazer on particularly northeast Atlantic rocky shores. And their grazing activities are akin to a cow or a sheep in a field. You know, if you took a cow or a sheep away from a field and waited 500 years, you might get climax oak woodland. But if you build a little fence with chicken wire, which I did for my PhD, and exclude limpets, within 6 months, you get 100% stand of fucoid seaweeds, which reaches full size within about a couple of years. So their grazing activities are basically controlling algal vegetation on moderately exposed and exposed shores throughout most of the northeast Atlantic, well, for all of the northeast Atlantic, other than very, very sheltered shores where the seaweeds win and the limpets don't do so well. And we think the limpets don't do so well on shelter shores because they don't like sediment, which we've done a bit of research on, some work I did with Laura Araldi at the MBA when she was a visitor. They also are subject to more crab predation. Another piece of work which I did jointly with Richard Thompson, Anna Silver as a student, and Deanna Boaventura, where we looked at mobile crab predation on rocky shores. And certainly, if we exclude crabs by little cages on more sheltered shores, limpets survive. So I think combination of siltation, and the siltation's aided by ascophyllum canopies, which promote algal turfs. The algal turfs trap silt, and on a very sheltered rocky shore, you'll get limpets in little clearings, which are just managing to keep clear. So they don't win. The limpets don't win on shelter shores, but on more exposed shores, they're the dominant grazer from more or less the top of the shore down to the algal turf zone. And at that stage on the shore, the seaweeds can grow faster than the limpets can graze. So that's where either side of low waters where the basically seaweeds win and limpets just can't graze fast enough. So we've done experiments where we've excluded limpets throughout Europe, part of a European research project called EuroRock, which showed that exclusion of limpets all the way from the Isle of Man down to Portugal reduced seaweed cover on the seashore. And we did think that in southern Europe, where it was hotter weather, that the unfavourable, stressful conditions when the tide was out would actually limit algal growth. But even in hot conditions, even in experiments we set up over the summer in the worst conditions, removal of limpets led to proliferation of seaweeds, even in the south of Portugal. The nice thing about rocky shores, though, is you can actually see the patterns.
Yeah.
If you're working on sand on a mud flat or a beach, you've got to actually dig the sand, sieve the sand, look at the species, identify them, and then stick them into some kind of complex multivariate analysis before you get any idea of the underlying pattern. But on the seashore, you can see patches of seaweed, patches of barnacles, and the patterns are very, very apparent. And that's what makes rocky shores such an important test system for experimental work.
And so what are the bigger questions that you're trying to answer in your research?
Well, at the moment, my research is in the sort of, shall we say, trending towards retirement phase. And I suppose I'm trying to tie up a lot of loose ends and undone things that I've been working on for the last 50 years. But throughout my career, the three main things which have interested me on rocky shores are what's the relative role of physical factors as ultimate factors and biological interactions as proximate direct factors in setting distributions and affecting the structure and composition of rocky shore communities. And then about 10 or 15 years ago, working with Stuart Jenkins and other people, Taz Crowe, Richard Thompson, we got interested in what the implications of biodiversity on rocky shores were for ecosystem functioning, how important biodiversity was for the way that the ecosystem worked, and again, using rocky shores as a model system to explore this. Some very nice work was done by a student at the MBA, John Griffin, who's now a full-time academic at Swansea University, with Stuart Jenkins and Richard Thompson and myself, where rock pools were used, or rock pools were simulated in the seawater hall at the MBA to understand how diversity affected ecosystem processes. And I suppose the other thing that I've been doing in parallel with this experimental work, and it was something that I decided to do when I was in Manchester for a few years, and I used to come down to the MBA to work in the summer because the University of Manchester had helped establish the MBA in 1888 and the lab, and we actually had a free table there for perpetuity, so I could come and use the MBA facilities for nothing because the University of Manchester had given 50 guineas a year since 1887 to the laboratory. So what I decided then was that I could do broad scale and long-term work, and the interest in this was sparked by a field trip with Alan and Eve Southwood in April 1980, where we looked at various sites that Alan had been looking at for many, many years, since the 1950s, starting at Lyme Regis and then going to Portland, a couple of sites in Dorset, and then Swanage, chasing the tide out as it gets later along the channel. And that got me interested, and I think Alan deliberately got me interested in long-term and broad-scale observing. And one of the things that prompted this further was when I came to the MBA, my postdoc, which as Alan said was full of jargon, was looking at using limpets as a model for niche differentiation. Niche theory was a very trendy subject in the late 1970s, early 80s. And I was interested in using two coexisting species of limpets, Patella depressa, a warm water species, and Patella vulgata, a cold water species, and looking at their competitive interactions and trying to use that as a model to understand and inform niche theory. I'd read all the literature from the 1950s, and it said that in the Plymouth area, many sites, there are about 50-50 populations, and this seemed like a good model system to do various removal, density manipulation experiments. So that also prompted my interest in long-term change, because in the 1980s, it was the end of a cold period. And when I turned up, I actually found that the warm water limpet was much less common than it had been in the balmy 1950s. And when I actually started this long-term and broad-scale work, I was actually interested in getting colder. And in the early 1980s, there was lots of stuff on the TV and in newspapers about a new ice age coming, because from 1962-63 onwards, it had been a very cold period. So that's my other interest. And my final main research interest has always been on more applied ecology. And I've been interested in urban coastlines, particularly recovery from pollution incidents. I did a lot of work in Liverpool, from Manchester and Liverpool, on restoration of disused dock basins, essentially inside-out rocky shores with artificial rocky shores in the middle, how to restore those for urban renewal schemes. And more recently, I got involved in a lot of work on what's now called eco-engineering, but it wasn't called eco-engineering when I started it, when I started getting involved in it, which is actually how you could modify artificial coastlines to increase biodiversity. So if you're going to build a sea defence, try to make it multifunctional and try to design it with biodiversity in mind rather than just engineering functionality in mind. And that area of research has really exploded. And a lot of this work was done with, in recent years, has been done with Louise Firth, who was at the University of Plymouth, now at University College Cork, and also with Richard Thompson. I mean, Richard Thompson led a big chunk of an EU project that I was involved in the 2010s. And this is basically on trying to apply knowledge from natural rocky shores to make urban rocky shores or sea defences more attractive for marine life, and also to put in place ecosystem services, one of which, of course, are cultural ecosystem services, because British people love rock pooling. So I always say eco-engineering is not rocket science, it's more like rock pool science.
And so where are your favourite rock pools in this country?
Well, every rock pool is different. And every rock pool is different because of different sizes, different shapes, different depths, different species pools to inhabit them, and different underlying geology, which affects the ultimate factor affecting how many rock pools and what type are there. I think some of my favourite rock pools would be on limestone shores in areas where there's the intertidal sea urchin, intertidal and subtidal sea urchin, Paracentrotus lividus. You get some of these in Ireland. The species doesn't occur in the UK. They occur on the French coast. They occur in Portugal. So I think some of my favourite rock pools are in Portugal. And I've been very fortunate in I've been involved in work on both natural and artificial rock pools in Portugal for some time now. And I was very pleased when my most recent Portuguese student, and probably my last formal Portuguese student, graduated this June after doing some splendid work on rock pools, both natural and artificial. And I think some of my favourite rock pools are definitely in Portugal. But Wembury's pretty good as well.
We hope you enjoyed the podcast. Become a member of the Marine Biological Association and be part of a global community advocating for the ocean. You'll receive 4 copies of our beautifully produced magazine, The Marine Biologist, and a host of other benefits. simply visit www.mba.ac.uk for more information.